All right, I'm going to show you the strategy I would use for solving for x on problem 4. We call it fraction busting in my class, where you multiply the whole expression by a common denominator. So in this case, that denominator is 5. 5 times 3 is 15x. 15x divided by 5 would just give us 3x. And 5 times 9 is 45. Then we can continue to solve it by dividing both sides by 3, and x equals 15. You may use a calculator to solve these if you need to for the decimals. Same type of process can be used for number 2 and number 3. This is a digital lesson, so if your teacher doesn't have it open or available, just go ahead and keep track of notes that you need to make in Lesson 11's workbook pages. Otherwise, if it is open, feel free to follow along digitally. What questions do you have after watching the animation? So down here you can see it said they were checking in. Now they're getting through security. They're boarding the plane. And then they start to take off. My question is, how long of a trip would it take for it to be faster to travel by car than by plane? And also in this scenario, who's going to arrive first? What do you need to know to answer your questions? I need to know the speed of the car, the speed of the plane, how far they are traveling, and how much of a head start the car gets. You are going on a vacation from San Bernardino, California. Choose a destination for your vacation. So I'm going to go see Mount Rushmore. And it tells us down here that the distance I'm going to travel is 1,019 miles. You do not have to choose the same destination that I do. You can choose one of the other locations and then just confirm your destination when you're ready. Do you think you should drive or fly? Well, based on my map, I think this is one of the farthest distances. This one in Texas might be farther. Oh, it didn't say. Yep, this one's a little bit farther. But being that it's so far, I'm going to assume that it's probably faster to fly. Make some assumptions about both methods of travel. Adjust the slider to show your assumptions. So the car speed. Here we have some different speeds. Now, I know that typically on highways or freeways, you can travel between 60 and 65 miles per hour, sometimes 70. But I also know that on small town roads, which I'm assuming we're going to pass through, it can go as low as 25 miles per hour. So I'm going to assume that the car is traveling at 55 miles on average because it'll travel faster in some spots and slower in others. So I'm going to stick with 55. Now, airport time before boarding. Typically, you park your car, maybe you take the tram from your car in the parking lot to the airport. Then you have to check in, maybe check some bags. Maybe you stop and get a coffee or breakfast. You go through security, and then you wait for your plane. So I'm going to assume that this actually takes longer than an hour. And if the airport's really busy, it might be closer to 3 hours, but I'm going to go with 2. The plane speed. I don't know a lot about plane speeds, but let's see what it recommends or what some options it tells us are. It doesn't give us any information other than the speed. And I don't know how fast planes go, so I'm just going to stick it in the middle. If you know more about planes than I do, feel free to move that slider accordingly. Airport time after landing. So after you land, the plane has to taxi to the airport from the runway. They hook up the little thing for you to get off. You walk through the airport. You might stop at the restroom. You pick up your bags, or you wait for them to come out. You pick up your bags, and then you've got to go from the airport. So I'm going to say this is going to take 45 minutes. Because we got to wait for all the people in front of us to get off the plane and then go get our bags. So here it says we're headed to Rapid City. We decided to drive. Rapid City is 1,019 miles away, and we're driving about 55 miles the whole time. Let's look more closely at the driving options. With the assumptions you made, how long would the trip take if you drive? So if we're going 1,119 miles, and we're going 55 miles per hour, if we divide, that'll tell us how many hours it will take us. And we'll probably end up rounding to approximate, because this comes out to 18.527 repeating. So I'm going to say this is about 18 and a half hours. Or we can round up to 18.6 just to give us a little bit of extra time. Maybe because we stopped at the restroom. We had to make a pit stop. Stop for lunch. Alright, so here we have the options for our plane. And it says, with the assumptions you made, how long would it take if you fly? So based on the miles and how fast we're going in the plane, if we divide those, that gives us 1.787. So I'm going to round that up to 1.79. But then I also need to think about, okay, I had to arrive 2 hours early, so I'm going to add that. And I also have 45 minutes. Well, if we did 45 minutes out of 60 minutes in an hour, that is 0.75. And if I add all of those up, that gives me 4.54 hours. you calculated your driving time to be 18.6 hours and your flying time to be 4.54 hours. You also said that you would fly. Would you change your mind, and why? No, I would not change my mind. Flying was faster. Now, it might be more expensive depending on how much we pay for fuel. We don't have that information, or how much the flights cost. So there are some other factors to consider, but based on the speed of this, I would say I'd still fly. Use the animation to check your calculations. So this says 4 hours and 32 minutes. Well, 32 is just over a half, and 0.54 is just over a half of an hour. My car arrived in 18 and 32 minutes. So if we were to change that 32 minutes to a decimal, we could do 32 out of 60. And that would tell us what that number, or those number of minutes, is based on the hours, and that comes out to 0.53. So this is really 4.53, and this is 18.53. Remember, we rounded up just to give us some extra wiggle room, because we had the option of 18.5 or 18.6 if we wanted to go up, or if we wanted to just round it accordingly. So we are within a reasonable range from our decimal value. So did your calculations match the animation? Is there a distance where driving and flying take the same amount of time? So it says some new assumptions. Your car is traveling 65 miles an hour. You take 2 hours at the plane before you board. Your plane travels 75 miles per hour, and the time after is 30 minutes. First, define your variable. So that way I can write my expression for the time it takes in the car would be 65 miles per hour. And if I multiply that by the number of miles I need to travel, or no, if I divide the number of miles I travel by 65, that will tell me how many hours it takes. Write an expression that represents the time it takes to complete the trip by flying. Well, the miles would still be divided by the speed, but this time I have to add the 2 hours for the boarding, and 30 minutes is a half of an hour. So I have my expression for the drive time and the flying time. Write an equation showing that the driving time is the same as the flying time. So that would be the driving time equals the flying time. And now we'll solve it. Well, 2 and 0.5 can be combined. They are like terms. Then I'm going to multiply both sides by 65. That's going to get rid of this one, turning it into m. And this will be 65m over 575. And I also need 65 times 2.5, which is 160.5. Then if I multiply that whole equation by 575, that'll eliminate this denominator. So that would be 575m, and then the 575s here would divide out, so we'll have 65m, and then I need 575 times 162.5, which is 93,437.5. Now it looks extreme, but we still have some more math and calculations to do. So I'm going to subtract 65 from both sides, or 65m, excuse me. 575m minus 65m is 510m. And here I still have 93,437.5. And my last step is to divide by 510 on both sides. That will leave me with m and 93,437.5 divided by 510 is approximately 183.2 miles. You said the distance is 183.2 miles. Does your solution compare to the animation? Is there anything you would change in your equation? So he had 183 miles. My solution is the same, or about the same, as the animation. Again, it appears that they rounded to the nearest whole number of miles, and we rounded to the tenths. Is there anything you would change in your equation? I would leave my equation the same, but I would round my answer to the nearest number of miles. Choose a detail. Okay, so here we have to think about some details. Maybe you have priority check-in, so you get to kind of cut some of the line. Maybe you have headwind or tailwind on your plane. Maybe they've improved the roads, or you got a flat tire, or lots of traffic. I'm going to go with a flat tire. How do you think the detail you chose would change your trip? It would increase or add time to the car ride. So I would probably say that they travel fewer miles for the time to be the same. So how would we change our equation to account for the detail you chose? It says it increases the driving time by 30 minutes. So my new equation should say x over 65 plus 30 minutes is 0.5 hours equals 2 plus x over 575 plus the half hour for departing, or airport time after landing. It doesn't ask me to solve it though. But if we were to subtract 0.5 from both sides, then it would leave me with a 2 here and then the two fractions. And we could multiply again by 65 and 575 to eliminate those denominators. That's it for lesson 11. Keep in mind if you chose a different destination or different details that your answers might be slightly different from mine. Check back for lesson 12 coming soon.